Hello, my name is Fiona Play, and I am a scientific product specialist here at Simulations Plus. Welcome to this ACAT Plus tutorial. In this tutorial, you will be introduced to the ACAT Plus model, and you will use an example project based on sulfasalazine and mesalamine. You will learn how to implement the microbiome metabolism into GPX and how to access the simulated local disposition of a low permeability drug that targets the colon. Let's start with the ACAT Plus model introduction. The Advanced Compartmental Absorption and Transit model, known as the ACAT model, that you can see here on the left, has been enhanced to incorporate multiple tissue layers surrounding the enterocyte layer, which makes it more suitable for simulations of local drug disposition. Each gastrointestinal segment has 4 extra layers comparing to the ACAT model. So you have the mucus layer, the mucosa, the submucosa, and the muscularis propria layer. The concentration in each individual tissue layer and the whole gut tissue could be simulated, which are difficult to measure. The mucus layer has been divided to multiple sublayers in order to describe the distribution delay from the lumen to the top of the enterocyte, caused by diffusivity and binding in mucus layer. Now, you can see the ACAT plus physiological parameters table that lists the specific physiological parameters of each tissue layer. So you will find the thickness and the blood flow for those layers. In order to simulate the compound with very low permeability or the modified formulation to deliver the drug to the colon, extra colon segments have been added to the ACAT Plus model. So here on the left side, you can see the ACAT model with the ascending colon being the last segment. And if you switch to the ACAT Plus model that you will see here on the right, you can see that some extra colon segments have been added. So you have the transverse, the descending, the sigmoid colon, and the rectum. Also, to better describe the transit delay in large intestine, ACAT Plus allows user-defined subcompartments for each colon segments. So this is something that you will see on the ACAT Plus table. And here on this column, you will see the number of subcompartments, and those values for the lower part of the gastrointestinal tract can be edited. Now, a few words about the example project. Sulfasalazine and mesalamine are first-in-line treatments for inflammatory bowel diseases. Sulfasalazine is a low permeability compound which is metabolized by the gut microbiome in the colon lumen into mesalamine, a drug that also exerts its effects in the colon and rectum. The sulfapyridine is the second metabolite formed in the colon, which is non-active. Let's now switch to the GPX to see first how to implement the microbiome into the sulfasalazine model. Currently, we are in the sulfasalazine and mesalamine example project that we will use in this tutorial. This example project has already been fully set up except for the microbiome enzyme that we will add. Let's move to the compounds view. Here we will select the sulfasalazine compound if not already selected. You can review the inputs in each panel by clicking on them. And you will see that it has been already set up with everything. Now we will open the enzyme kinetics panel. We will now add the microbiome by clicking on Add. So here we will leave the species as human, and we will also leave the wild phenotype. Under the enzyme column, we will select the microbiome. For the location, we will select lumen dissolved. We will also change the Vmax and Km values. We will enter a Km of 20 milligram per liter and a Vmax of 0.005 milligram per second. Now you will click on Save at the top right of your project and then on OK. Don't forget to save your project frequently. Now let's move to the physiology's view. Make sure that sulfasalazine is the selected compound. You will see one physiology available, which is a physiology for a human of 30 years old and 70 kilograms. Now we will open this gastrointestinal panel. And if you scroll down a little, you will see that the ACAT Plus is enabled. It has been toggled on. And if you scroll down again a little bit, you will indeed see that you have the extra colon segment present here. So you will find the transverse, descending, and sigmoid colon, as well as the rectum. If you again scroll down, you will see after the ACAT plus physiological parameters table, the enzyme distribution, in our case, the microbiome lumen dissolved expression. As you can see, there's no expression in the upper part of the gastrointestinal tract, and it's in the colon part where you will see that we have a microbiome expression. Now, let's move to the pharmacokinetics view. Make sure that the sulfasalazine compound is the one selected, and then you can click on the compartmental panel where you will see that a two-compartmental model has been entered. This model has been created and validated based on preclinical IV data. Now, let's click on the simulations view. We will select the HVPO sulfa 1 gram suspension, if not already selected, and click on Run Simulation here. Once the simulation is done, the software will automatically switch to the analysis view, and you can observe that the simulated CP time matches the observed data pretty well for a single dose of 1000 milligrams of sulfasalazine administered to healthy subjects as a suspension. Now click again on the simulations view. We will run another simulation, which is the HVPO sulfa 2 gram and coat tab, and then click on Run Simulation. Again, once the simulation is done, you will see the analysis view with the CP time. And you can see here that the simulated CP time is reasonable compared to the observed data for a single dose of 2000 milligrams of sulfasalazine administered to healthy subjects as an enteric-coated tablet. We will now move back to the compounds view and select another compound, which is the one called sulfasalazine with MET. In this case, it's the exact same setup of the sulfasalazine compound. The only difference, as you can see here under the enzyme kinetics panel, is that the metabolite is now entered. So we entered the mesalamine instead of none, as it was previously the case. So this represents the sulfasalazine being metabolized by the microbiome into the mesalamine in the gut lumen. We will now simulate both sulfasalazine and mesalazine CP time profiles. Click on the simulations view, and then we will click on the simulation, which is called HVPO MESA 2 gram enteric coated tab, and click on Run Simulation. Because the simulation contains the ACAT Plus model, the time for the simulation to complete can take longer than usual depending on your computer's power. Again, once in the analysis view, you will see the simulated CP time curve for mesalamine and sulfasalazine for a single dose of 2000 mg of sulfasalazine administered to healthy subjects as an enteric coated tablet. Now, to be able to distinguish both compounds, let's expand the additional features by clicking on the plus here. You will select the compound and then click on Color By. Now let's put the plot on the semi-log scale to have a better view of the mesalamine simulated and observed concentrations that appear now in green. We will click on the minus for the additional features and expand the plot settings by clicking on this plus, and then the plot options by clicking again on the plus. If needed, you can expand the plot settings and plot options by dragging to the left here the plot. Now you will move to the dependent axis, that is the concentration, and change this to logarithmic. You can close it by clicking on the minus here, and you will see the mesalamine observed data and simulated concentration. Click on the observed data. You can see under the summary of data profiles that we have 3 exposure data type. And as you can see, those 3 correspond to the observed concentrations for the 3 simulations that we just ran. So you can see 2 exposure data corresponding to sulfasalazine concentration for a 1 gram suspension administration, and for a 2 gram enteric coated tablet administration. The last one corresponds to mesalamine observed concentration after a 2 gram enteric coated tablet administration of sulfasalazine. We also have 1 in vitro dissolution release, as you can see here. And so let's select it by selecting the in vitro dissolution release data type in the drop-down menu. If you scroll down, you will see the dissolution data fitted by the Weibull function for ACAT. ACAT is the brand name for one of the mesalamine delayed release tablets. And in the study, patients received 1200 mg of ACAT per day during a week to reach the steady state. On day 8, biopsies were done on those patients. So we will now enter the rectum concentration that was measured with those biopsies. So let's move back up and select again the exposure data as data type. Click on Add next to the group name, and you will enter the name ACAT gut tissue concentration. Then click OK. You will then click on the Add button next to measurement type, and you will call it rectum concentration. You can then click on OK. Once you are in the rectum concentration, you will change the concentration from nanogram per ml to microgram per ml. Now you will enter a time point of 176.5 hours, which corresponds to the data point when the biopsy was performed, and then enter a concentration of 108.5 microgram per ml. You can now see on the plot the measured observed data that you just implemented. Now, if you scroll down, you will see a table where you will select gastrointestinal tract for the module. Under section, you will select the rectum. Under compartment, you will select the gut tissue. And as you can see, the state is already filled with the concentration present. Now we will save it and click on OK once it's saved. Now let's move to the simulations view. We will select the simulation called Patients 400 milligram times 3 1 week CR tab ACAT DVOS. Once it's selected, you will click on the Run Simulation button. So once the simulation is complete, the analysis view will appear and you will see the simulated CP time of mesalamine at steady state. You will now change the mode that is currently as the key view mode to the deep view. You will then expand the mesalamine by clicking on the gray arrow, then gastrointestinal tract, concentration, gut tissue, and here you can see that all of the ACAT plus segments are available. In our case, we will select segments from the cecum to the rectum. You can see that now concentration present is available for selection. So you will click on it and you will see the mesalamine gut tissue concentration for all the ACAT plus segments that we just selected on the plot. Now we will add the measured rectum concentration that we just added into the observed data. To do so, we will expand the exposure data here by clicking on the arrow. Then click on the ACAT gut tissue concentration and click on the concentration series. You will see the rectum concentration appear. To select it, you will hold down Control and select the rectum concentration. Now both measured and simulated concentrations are selected. Let's now differentiate the rectum concentrations from the other segments by coloring it. To do so, expand the plot settings by clicking on the plus. Now you will select the measured rectum concentration and also the simulated one. So here you can hover over to see the entire name. And here you can see rectum. So you will hold down Control and select this. Now that the rectum concentrations are selected, you can click on the plus on the plot options. Again, to be able to see the entire window, you can drag to the left the plot. Here you will scroll down and under plot options, you will select the square next to options to select another color than black, for example, red. Then you will click on OK. You will then select this other square next to line options and the points and select red as well. Click OK. You can now click on the minus of the plot settings to see the plot, and now you can see in red the measured concentration in the rectum and the simulated one. As you can see, the measured rectum concentration is in the same rank as the simulated concentration. You can also unselect the other segments by unchecking them to be able to focus only on the rectum concentration. So to do so, you will uncheck the other segments. Here, you will now only see on the plot the rectum observed and simulated concentrations. That brings us to the end of the ACAT Plus tutorial. Thank you for watching. If you would like more information, please visit our website at www.simulations-plus.com, or you can email us. Thank you.